Electric field due to a uniformly charged arc. Consider a uniformly charged arc of radius a, whose charge per unit length is lambda, kept on the xy plane. We will calculate the electric field at the center of arc, such that the end A and B of the rod subtend angles alpha and beta as shown. The electric field at origin is the resultant of the fields due to different sections of the linear charge, varying from A to B. Consider a small elemental charge, dq, located between angles theta and theta plus d theta. Length of this element is equal to a d theta. Charge contained in the element dq equals to lambda a d theta. The magnitude of the electric field dE at origin due to this small elemental charge is equal to k dq by a square, which equals to k lambda d theta by a. dE makes an angle theta with x-axis. So, it can be split into dE cos theta along x-axis and dE sin theta along y-axis. Net electric field at O due to the uniformly charged arc is given by integral dE from minus beta to alpha. So, E bar equals k lambda by a, integral cos theta d theta from minus beta to alpha I cap, plus integral sin theta d theta from minus beta to alpha j cap. Upon integrating and substituting the limits, we get E bar equal to k lambda by a sin beta plus sin alpha I cap plus cos beta minus cos alpha j cap. This is the general expression for electric field due to a uniformly charged arc. Electric field on the perpendicular bisector. In this case, alpha is equal to beta. So, E bar becomes 2k lambda by a sin alpha I cap. Electric field due to semicircular charged arc. In this case, alpha and beta are equal to pi by 2. So, E bar becomes 2k lambda by a I cap.